Welcome to Data 606, Capstone in Data Science, Stock Prediction, Semantic and Sentiment Analysis. Stock price is entirely governed by two factors, what the owner wants to sell it for and what the buyer is willing to pay for it. Many factors influence their decisions. This project will focus on price prediction based on semantic analysis and sentiment analysis on social media, Google search terms, and news articles over time. The main idea here is that people make decisions about what stock to buy and the price they're willing to buy or sell it for. There may be predictive indicators in media publications. Sentiment analysis using TextBlog or Vader provides a reliable metric expressing positivity, negativity, subjectivity, and sarcasm. This effort will explore the potential to establish a semantic scale of topic modeling to create a semantic score expressing a semantic score for stock valuation using bear market and a bull market score from -1 to 1. So some caveats, this project is still in the develop the dataset stage. Working in the EDA, data acquisition is underway, but not yet complete. Working data processing of extracting data, storing the data into processable forms, developing the data structures to support machine learning, etc. is underway. Some learning curves getting to this stage include learning how to use GitHub. I had never used GitHub before. GitHub on the laptop environment is complicated by if you do an edit on one platform and the other platform is not in the same set of version control. And so learning how to work in a GitHub environment, how to program in a GitHub environment and have all of that flow, learn how to do all of those stages correctly. That's quite a learning curve for me. Processing the queries to Google to get URLs on the topic, that was very difficult. Google's blocking. There's not good documentation on how to perform Google queries without Google blocking you. There are date range issues where if you try to do a date range on the Google API, it doesn't work. You can do a Google search in a scripting environment where you actually set up a set of software and web scrape Google. They discover that you're a robot and they shut you down and block you. So I have finally succeeded in getting queries to Google to not block. So I'm very happy about that. I'm very frustrated by lack of progress in actually getting the data that I need to process. So I've got a newspaper 3K package that I've downloaded. So I'm able to point at an individual URL, download and parse that article, and then store that into a data store. So I'm using a dictionary of data frames to store the intermediate results. I've got Twitter data from a previous project where we were doing sentiment analysis on stock prices. So I've got 150,000 articles on the topic. But published articles are better than Twitter data. There's a higher level of trust in a curated article as compared to a social media tweet by an individual. So the core of this project that differentiates it from my previous project is that here I'm going to be using word vector semantic analysis. Word vectors provide a semantic analysis opportunity to explore a relationship between words in a corpus. So in this case, France and Italy are quite similar to one another. Ball and crocodile are not similar to one another. And if you can actually do vector math where two vectors can be compared with one another. So you can actually do vector math where Rome plus Italy minus France will be equal to Paris. So there's a way to do vector math on the word vectors so that the similarity and differences between words can be examined. Exploring cosine similarity with vector math provides a toolbox of methods to use in evaluating semantic relationships. However, the available body of work on this subject is very sparse. and there's very little work on purpose-driven semantic models being developed. Cosine similarity math provides methods to perform linear algebra functions to identify semantically similar words, and this is the basis of this semantic effort. So leveraging word vectors from various sources, this project will use neural network prediction to isolate and score the predictive benefits of various sources. If there is a predictive relationship, then explore the feature sets and semantic relationships of the useful word vectors, authors, news sources, etc. If a predictive word vector corpus can be isolated, then this would reflect several benefits: utility of the source, the news source, author, semantic corpus development, exploring the semantic nature of knowledge, advice, opinions, etc. for the particular purpose. A semantic score of this nature could be provided in a semantic model that would be useful to inform investor decisions based on evaluation of media sources. So far, data sources that I've collected are Google searches. I've got a Google search script where I have 2 search terms, and I've amassed 11,150 URLs. News articles extracted from news outlets using the newspaper 3K Python module. So this data set includes 11,150 articles and 1,872 columns. The top level domain list is currently 3,300 sources. It's unclear at this moment how many of these sources are newspapers that can be built using the newspaper 3K package. So the way that the newspaper script is applied at the moment is that each of the URLs will net one document. That one document is parsed into columns in a dictionary of data frames. However, the newspaper module can actually download an entire newspaper. So I haven't explored that part of the newspaper module yet. So this 11,000 articles could easily balloon into hundreds of thousands of articles. So research questions or hypothesis. The base question is, how successful would predictions be if intent and semantic modeling were included along with sentiment? So I'm very interested in the semantics of stock advice expressed by authors and people in their social media posts. What was the intent of any particular post? Sentiment is easy to quantify, but what was the sentiment about? What was the intent of the post? Was it informative, informational? Was it directive? Was it influencing? And then what is the spectrum of intent expressed in these corpuses? So basically, how successful would prediction be if intent and semantic modeling were included along with sentiment? So discussing the research process and the steps involved moving forward, some of the next stages are identifying word vectors that have predictive benefits, word vectors as feature sets in a predictive neural network model. Word2Vec provides modeling and word embeddings. So part of the word vector feature sets will be the full text, lemmatized text, summary text, keyword text, bigrams, trigrams, and phrases. So some of the initial EDA results, initial data acquisition is going slowly, although I have gotten to a level of success on that. I believe I can move on to some of the next stages. Google was extremely frustrating. I'm working on doing word embeddings using Spacy, sentiment analysis using TextBlob, stock prices using Yahoo, exploring the newspaper 3K module to download, parse, and create a data structure to store the resulting articles. I'm trying to do some research on vector math, vector addition, subtraction, and the most similar functions of particular words in a corpus, but developing a semantic score and a spectrum of intent in the individual articles is something I'm trying to work out. And then predicting the semantic intent of a particular article, A, to determine relevancy to this topic, and also to determine what the author is actually expressing, and how to take the terms and the corpus that are endemic to those articles and leverage it as to use it as a predictive scoring methodology for stock prices. So the machine learning models that I'm going to be working with are topic modeling, clustering, and neural network predictions of stock price based on word embeddings. Long and short-term memory, LSTM, recurrent neural network to examine sentiment scores and word vectors across a time period. The main objective is feature selection and relevance of semantic intent to prediction. It's unclear until the experimentation takes place whether a random forest or a convolutional neural network will be most useful for the purpose of feature selection and determining what particular features are useful for producing a price predictive model. So it's a little naive to assume that models created in this project will net a stable and reliable stock prediction methodology that doesn't require actual domain knowledge of the forces that drive stock prices. However, the methodology of evaluating investor behaviors and influencers is useful in many domains. So focusing on news media and social media can provide access to expert and pseudo-expert advice, which presumably could be used to predict stock prices. The focus shifts to modeling the predictive utility of the authors and their advice to the predicted price. Machine models produced would reflect a predictive score of the specific author and the semantic score of that advice.